So before we start discussing this exponent rules list, let's agree on some notation and some words. Typically speaking, you're going to have a number in the base and a number in the power. The letter A in this case is supposed to represent some random number, and the letter M is supposed to represent another number. The A is usually called the base, and the M is called the exponent or the power, okay? So there's a couple different names for that. On this particular list, there are times when you see different letters in the base, A and B for instance, and in that case, the A and B are supposed to represent two different values or two different numbers. And there are times when you see different letters in the power, M and N, and that again is supposed to mean that there are two different numbers possibly in the exponent. So we begin with the first exponent rule, which says anything to the power of 0 is equal to 1. This does not include 0 to the power of 0. So if I put 5 to the power of 0, you're supposed to say 1. If I say what's negative 3 to the power of 0, you're supposed to say also 1. The second rule in this list is the negative exponent rule. And generally speaking, it just means that when you have a base with a negative exponent, it wants to be on the other side of the fraction. So if it's already on the numerator, bring it to the denominator and vice versa. So for example, if I give you 3 to the power of negative 2, that's supposed to be written as 1 over 3 to the power of 2, and you make the negative go away, and you put a plus instead. However, if it was already, for example, like 5 divided by 3 to the negative 2, then you leave the 5 alone because the 5 has an exponent that is positive, and the 3 has a negative exponent, so it wants to be written on the numerator. So you just write down 3 to the power of positive 2 on the numerator. Next is the product rule, and the product rule has two bases being multiplied, but the exponents of those bases are different supposedly. So for example, x to the power of 2 multiplied by x to the power of 3. The base is the same, it's repeating twice, but the powers are different. And according to the rule, we're supposed to add 2 plus 3 together and then figure out that this is equal to 5. Now what's the reason for that? It's very intuitive. X to the power of 2 literally means x times x. And x to the power of 3 literally means x multiplied by itself 3 times. So in total, how many x's did I write? Well, I wrote 5. So it makes sense to add 2 plus 3 because 2 plus 3 is going to be 5 at the end. So that's the motivation behind the product rule. Next, let's turn our attention to the quotient rule. And in the quotient rule, we typically have a fraction with bases on the numerator and denominators that are identical, but the powers may be different. So you may have 5 to the power of 7, for example, divided by 5 to the power of 4, for instance. The common thing here is that the base 5 and 5 is repeating. And we can only use this rule when the base is repeating. And in this case, according to the rule, we do the numerator power minus the denominator power. So in this case, we do the 7 because that was on the numerator first. Then we subtract the 4 because that was the denominator exponent. And we always follow that format regardless of whether the 7 is bigger than the 4 or not. So like for instance, there are times when we have 5 to the power of 1 divided by 5 to the power of 4, for example. We still do 5 to the power of 1 minus 4. So the base, again, we check that the bases are identical. Then we do the exponent power first minus the denominator exponent. Be careful because there are situations when the denominator has a negative exponent and you may need to put double negatives when you write the number on that side. Next up, we have the power rule. And what's going on with the power rule is that you have a base raised to an exponent raised to a second exponent. So we have power to power. I like to call it power to power because it reminds me that there are double powers going on in my exponent. So according to this rule, what we're supposed to do is multiply the powers with one another. So we take the number that was on the inside of the parentheses, which in this case is 2. We multiply it with the number that was on the outside of the parentheses, which is 4. And at this point, we get 3 to the power of 8. Be careful, this is different than the product rule that we mentioned earlier. So as a reminder, the product rule says, let's say you have 3 squared times 3 to the power of 5. We do not multiply the powers there. Instead, we add the exponent. So when the bases are multiplied, we add the exponents. And when the base is raised to a power again, what we do is we end up multiplying the exponents. So be careful and pay attention to that rule. Next up, we have the product to power rule. And this product to power rule basically says if you have two things being multiplied but raised to the same exponent, then the exponent goes to the first and goes to the second base in the product. So the 3 that was on the outside gets given to the 2 and also to the x. By the way, this also works if you have fractions raised to the same exponent. So for example, if I had 2 over x to the power of 3, this would still be 2 cubed divided by x to the power of 3. So even though it's called product to power, it also works for quotients. So it works for fractions where the fraction shares the same exponent. However, this rule does not work if you have addition or subtraction. So for example, if I have 2 plus x to the power of 3, this is not the same thing as 2 cubed plus x cubed. So be careful about that. That's a common mistake that happens here. Finally, we have the fraction exponent rule. And literally, this rule is meant to tell you what to do if you have a fraction in the exponent. So for example, if I have x to the power of 5 divided by 3, what am I supposed to do with this thing? How do I interpret it? The answer is you will just rewrite it as a radical. So you're going to put a square root and you're going to identify that the base is x and put it inside of the radical. So that's the first step. Next up, we are going to look at the 5 and we're going to look at the 3 and decide where those numbers go. And according to the rules, the 3 is going to be on the outside of the root. Typically, this is called the index. So 3 becomes the index, and 5, you've got a choice. You can put it directly next to the x on the inside of the radical, or if it's more convenient to you, you can write it on the outside of the radical, just like that, okay? So there are two choices for the 5, depending on what's convenient and what's not. And usually it depends on whether you have a calculator and you've got to compute the number or not. But regardless, they both give the same solution. And that's what the fraction power rule basically says and means.